Okay, so good afternoon and welcome to another Research Thursday session brought to you by Miami-Dade College Learning Resources. And today is my turn to present a Research Thursday session. And the topic I've chosen is how math helps us find information. My name is Jenny Saxton. I'm one of the librarians at Kendall campus. And with me today, helping me to moderate this session is another Kendall campus librarian, my friend and colleague, Aaliyah Shields, who is working the door, letting people into the room. And she's also going to be keeping an eye on the chat for us. So if you have any questions or comments as we go along, feel free to put them in the chat. And if I don't notice it, she will. And she'll do her best to field those questions and comments. So thank you, Aaliyah, for doing that. So the word math is in the title of this program, so I have to assume that since all of you are here, you're fairly comfortable with the idea of math. But if you are one of those people who tends to get a little nervous around math, not to worry. We're not going to be doing any hardcore math today. I'm not capable of doing that at this point in my life. So I hope we're all feeling very relaxed and very zen, because it's going to be okay. I promise you. But why this topic, though? Why am I here today talking to you about the connection between math and finding information? Well, as I mentioned a minute ago, I am a librarian. I help people find information. That's what librarians do. I am by no stretch of the imagination a mathematician of any kind whatsoever. However, if we go back in time, many moons ago, back decades, in fact, back when I was in college, I actually was a math major. I studied math, but unfortunately, I never really did anything with it because shortly after I graduated with a bachelor's degree in math, I totally shifted gears and went to graduate school to become a librarian. So I don't really remember a whole lot of the math I studied. So I know there are some math people in the room today, so please, if I get anything wrong as I go along, please let me know. But the reason for this topic is that when I was studying to become a librarian, I started to notice that some of the things that I had studied when I was studying math were really helping me as I was learning to find information. And these things continue to help me to this day. So that's what I want to share with you. So that leads me to my first question to you. When you need to find information, maybe you have a research assignment, maybe you have to write a paper or give a presentation, and you have to include a list of works cited or a list of references, and you need to find sources of information, or maybe there's just something in your own personal life that you need more information about, or maybe you're just curious about something and you want to learn more about it. Where do you usually go first when you need information? You tell me. You can put it in the chat, or where typically do we go? Don't be shy. Yes, that is the correct answer. Google. Right. We many of us go straight to Google, of course. Now, of course, Google is not the only internet search engine in the world, and it wasn't the first one. There were others that came and went, but Google has certainly emerged as the dominant search engine to such an extent that the word Google has become a verb over the years. You Google something, right? So far, I have never heard anybody say that they were going to Bing something. Have you? I haven't. I don't think people say that. But we do Google things, don't we? So let's take a second to talk about where that word comes from, because before Google, the search engine, was invented, the word Google, spelled slightly differently, Googol, meant something else. And Google, the search engine, was named after it. Does anybody know what a Google is? Some people might know. Yes, that is correct. A Google is a number, a mighty big one. And I will write it on the blackboard for you. Here it comes. So a Google, as you can see, is a very large number. It's a 1 with 100 zeros after it. And it can also be expressed as 10 to the 100th power. So it's, humongous. And it got its name back in the early 1920s when an American mathematician named Edward Kasner asked his little nephew, a 9-year-old boy, to come up with a name for a very large number. And he came up with the word Google. And around that time, there was also a popular comic strip character called Barney Google, who had googly eyes. So it's possible that the little boy may have been inspired by that. So just to illustrate how big a Google is, let's consider a number that's a little bit easier for us to imagine, 1,000,000, which is a large number in its own right. So as you know, 1,000,000 is a 1 with 6 zeros after it. And if you're lucky enough to have 1,000,000 $1 bills stacked one on top of the other, it would be approximately 358 feet high, believe it or not. So how high is that? Well, the Freedom Tower in downtown Miami, which is a building you might be familiar with, is about 289 feet high. So 1,000,000 $1 bills would actually be taller than that. And what if you had a stack of 1,000,000,000 with a B $1 bills? How tall would that be? Anybody want to guess? It's pretty tall. If you don't want to guess, I will tell you. A stack of 1,000,000,000 $1 bills would be 68 miles high. So how high is that? Well, Mount Everest, which is the tallest mountain on Earth, is just a mere 5.5 miles high. So a stack of $1,000,000,000 would be over 12 times the height of Mount Everest. So now we're talking like practically out in space. But what if you had a Google's worth of $1 bills? How high would that have to be? Who wants to guess? Any guesses? I know it's hard to wrap your mind around numbers like this. Um, all right, I'll tell you. It's actually a trick question because you cannot have a Google's worth of dollar bills, because if you did, there would not be enough room for them in the entire known universe. There just wouldn't be enough space. So yeah, it's a really, really big number. And if you really want to lose your mind, you can think about something called a Googleplex, which is a 1 with a Google's worth of zeros after it, which is, just insane. But of course, it's not the biggest number there is, because no matter how big a number you can think of, you can always add 1 to it and get a bigger number, right? So fast forward to the 1990s when the two guys who invented Google, the search engine, Sergey Brin and Larry Page, needed to come up with a name for their invention. And they chose the word Google because in those days, people knew what a Google was. And Sergey Brin and Larry Page wanted people to associate their search engine with large amounts, in this case, large amounts of information. Although when Google first started out, it didn't even have a fraction of the information that it has access to today. And by the way, the fact that they spelled it wrong, G-O-O-G-L, G-O-O-G-O-L instead of G-O-O-G-L-E, was just an accident, but it stuck. So they left it that way. But anyway, we've all experienced this. We've all experienced the vastness of Google when we use it to search for information. When you type something in, especially if it's a fairly broad topic like climate change, it's not unusual to retrieve millions, if not billions, of results. And of course, nobody has the time or energy to look at all these results. Typically, we only look at the first few or the first couple of pages of results, if that. And somehow, miraculously, not all the time, but a lot of the time, the information that comes up to the top of our list of results has a fairly good chance of meeting our immediate need. Not always. Sometimes you do have to dig a little deeper, and you certainly have to use some discretion. But a lot of the time, Google just works. So how does Google figure out which of the billions of items that meet our search criteria go up to the top? Well, of course, it does this with some pretty sophisticated and powerful computer programs called algorithms. This is probably a word you've heard before. An algorithm is essentially a procedure or formula for solving a problem or achieving a desired result. So a recipe, for example, is a kind of algorithm. If you have a recipe for apple pie and you follow all the steps and you follow them correctly, you'll end up with an apple pie. And in the context of computers, an algorithm is a set of instructions that tells the computer what to do. And what some of these algorithms do is something called relevance ranking, or sorting the results so that the ones that they think are going to be the most relevant for us come up first based on many, many pieces of data that are taken into consideration. So to illustrate this, let's look at just one of those many, many pieces, which is how many times the words we've searched for occur in an item on the internet. So this is going to be a grossly oversimplified example, but here you can see I've done a search for the word cloning, and in 0.39 seconds, Google's algorithms did their thing and retrieved 1.01 billion results. So out of those 1.01 billion results, let's just pick two of them at random, and we'll call them website A and website B. And website A happens to contain 1,000 words total, and website B contains 4,000 words total. And in website A, our search term cloning occurs 3 times. And in website B, our search term occurs 10 times. So based on this, which do you think is the more relevant website, A or B? Anyone want to guess? Everybody's very shy today. Well, you might think it's...
A?
Oh, yeah, go ahead. Go ahead. Which
Oh,
one?
I was just taking a guess. A.
You're correct. Why do you think it's A?
I would say because of the word count, the difference in the words.
You are exactly right. In order to, you might think it's B because it has the word cloning more times, but you do have to do a little behind the scenes math to figure this out. So you're correct. If you take 3 and divide it by 1,000, you get a score of 0.003. And if you take 10 divided by 4,000 words total, you get a score of 0.0025, which is a slightly smaller number. So if this were the only thing that Google was taking into consideration, website A would be ranked higher on our list of results than website B. But of course, this isn't the only thing that Google takes into consideration. It looks at a lot of things, including a lot of data about you personally. So it looks at things like where you are located geographically in the world, what kind of device you're using, what have you searched for before, what have you clicked on before, and lots of other things to try to get to know us so that it can deliver to each of us individually the information that it thinks is going to be the most useful or interesting for us. And like it or not, Google is not the only service that does this. Pretty much everything we use online uses algorithms to customize our online experience. Certainly the social media applications we use like TikTok and Instagram do this. YouTube, Amazon, Netflix, all use algorithms. And there are people who think this is a really great thing, and it is, because, the internet is so huge. We need help sifting through all of it. We can't do it ourselves. Some of it has got to be automated. But on the other hand, we have to remember that these are machines making these choices for us, and they can't read our minds. And at the end of the day, only we can decide whether or not the information the algorithms deliver to us is really going to do it for us. But sometimes that can be hard to know. And there are other concerns that people have as well about these algorithms. There are privacy concerns. There are concerns about biases that may be baked into some of these algorithms. So it can get a little controversial. And we can talk all day about the social and ethical aspects of this. But that's, obviously a different conversation for a different day. And of course, it's a problem that's not going to be solved anytime soon. In the meantime, though, is there anything we can do to work within this algorithmic environment to take back maybe a teensy bit of control and manipulate our searches to make them better and more effective for us? And to take advantage of one of these things we can do, we have to go back in time again and enlist the help of a mathematician, this guy. So say hello to George Boole. He was a mathematician, a British mathematician in the 19th century, and he is famous for developing a kind of algebra that is named after him. It's called Boolean algebra. And he figured out that there are 3 little words, common words that we use all day long, that have some magical properties that can help us to figure things out. Does anyone know what these 3 words there are three very short common words. Not I love you. The three other little words. Do we know? It's not the. That's not one of them. All right, I'll tell you. I'll take a sip of coffee and then I'll tell you. These three little words. Yes, you are correct. And, or, and not. And these are named after him too. They're called Boolean operators. And they, can help us figure things out. So, to see how this works, we have to first go back to day one of any math course you've ever taken and talk about sets. And in math classes, of course, you talk about sets of numbers like this one. This is the set of, like positive integers, right? But you can talk about other kinds of sets too. For example, you can have a set of dishes that go together. A set is a group of things that go together in some way, that have some kind of something in common. You can have a set of books that go together, like the Game of Thrones books. And I love this picture because, incidentally, the little pieces of paper that you see sticking out of these books, somebody actually took the time to go through and mark every single death in the entire Game of Thrones series. But anyway, this is a set of books that go together, right? Here's a set that you might recognize as musical instruments, right? That's what these all have in common. And you can have subsets, right? Sets within larger sets. So if we look at the little subset that we're looking at right now, these all have something in common. What do these musical instruments have in common? Do we have any musicians or music lovers out there? What is it about these instruments that make it a subset?
I'm not sure, but are they woodwind instruments?
Correct. They are the, wind instruments, right? Okay. So here's another subset. This one might be a little tougher. But what do all these instruments have in common? If you think about maybe what they're made out of, for the most part. What do you think? Some of them are gold, some of them are silver. So this was a little tougher. So these are instruments that are made out of some kind of metal, right? As opposed to instruments that are made out of wood or some other kind of material. So we have two subsets. So watch very carefully now, okay? We have wind instruments and we have metal instruments. I'm going to do it again. Wind, metal. Wind and metal. Do you see here any instruments that belong to both sets? You do it again. There's two of them.
From what I caught out, I'm not sure what instrument that is, but the skinniest one on the screen, I can't really tell what that is.
Yep, you're right.
Okay.
Yep, the flute and the saxophone, yeah, are the two instruments that belong to both of these subsets. So this is an example of the Boolean operator and, wind and metal, right? These belong to both subsets. So which of these animals has paws and barks? The cat, the dog, or the seal?
The dog.
Correct, the dog. Because the cat has paws, but it doesn't bark, and the seal barks, but it doesn't have paws. So the dog is the only one that belongs to both of these sets. So if you have the set of animals with paws and the set of animals that bark, in the center where they intersect, where the dog is, that is the Boolean operator and. Remember these Venn diagrams from math class? For these, we have to thank another British mathematician from the old days named John Venn. Um, but this helps us to kind of visualize this. So how about this question? What lays eggs not in trees? The chimp, the parrot, or the fish?
Fish.
Right, the fish, right? Because the chimp lives in trees, but it doesn't lay eggs, and the parrot lays eggs, but it doesn't live in trees, and you get it, right? So if you have oh, the parrot does live in trees, sorry. So if you have a set of animals that live in trees and a set of animals that lay eggs, the fish belongs to the second set, but not the first one, right? So you see the area in green. I hope nobody's colorblind, but if you see the area in green where the fish is, that's the part that does not belong to the first set. Okay, so this is an example of not. Here's a set of something, right? Months of the year, obviously. Here's a subset of months of the year. What do these months have in common? Why is this a subset? January, March, May, August, October. What do these months all have in common? You know the answer to this. I know you do.
Do they all have 31 days?
Yes, these are the months that
Okay.
have 31 days, correct. And there are different ways of remembering this. I don't know if you're one of those people who uses the knuckle method to remember which months have 31 days. If you hold your knuckle, your fists up in front of you, and you start from left to right, and you count off the months, each place where there's a knuckle is a month that has 31 days, and each place where there's an indentation between your knuckles is a month that does not have 31 days. I don't know if you do it that way. There are little poems that help you to remember this too. But anyhow, if we were meeting it face to face, I would be doing a little experiment with you, and Professor Espana knows this because I've done this in her classes many times. I tried to think of a way to do this efficiently in Zoom. I could have made a little Kahoot or, done a couple of Zoom polls or something to do this live with you today. But I honestly, since this is a drop-in session, I honestly didn't know if anybody was going to show up today at all. And in order to make this demonstration work, you have to have several people, right? So I thought I would just tell you about a previous time that I did this with a class to illustrate Boolean a little bit further. So here's what I did. I had a class of, I don't know, I don't remember how many, let me go back 1 second. I don't remember how many students were in the class total. It was maybe 30 people. It was a typical size class. And I first asked them to think about how many of them were born during a month that has 31 days. And then I asked them to think about whether or not they were left-handed. Okay. And then what I did was I asked the students, okay, raise your hand if you were born during a month that has 31 days and you are left-handed. So in order for you to raise your hand, both of these things had to be true for you. And when I did this, 5 people raised their hand. And then I said, okay, raise your hand if you were born during a month that has 31 days or you are left-handed. So either one of these things could be true for you, doesn't have to be both. And this time, 18 people raised their hand. And then the last question was I asked students, okay, raise your hand if and only if, remember that expression from math class? If and only if you were born during a month that has 31 days, but you are not left-handed. So in order to be eligible to raise your hand this time, you had to belong to the first set, but not the second one. And this time, 11 people raised their hand. So let's analyze the results here. So, and the number of students who belonged to both sets was 5. 18 people belonged to either the first set or the second one, not necessarily both. And then not was 11, the people who belong to the first step and not the second one. And if you notice, and is the smallest number, or is the largest number, and not is in between. And I got to tell you, I've done this in many a class, and almost every time, I can't say every single time, but almost every time, it comes out this way, where and is the smallest number, or is the largest number, and not is somewhere in between. So what does this have to do with research? Well, when you're searching for information and you don't get enough results, or you get too many results, use and when you want to narrow your search and get fewer results. Use or when you don't get enough results and you want to broaden your search and get more. And then use not when there's something you want to exclude from a search. And I'll give you some examples. Okay. Tattooing and piercing. If you're searching for this, what you are asking for is only those things that have both of these words. So if there's something out there on the internet that talks about tattooing, but it doesn't also talk about piercing, or something that talks about piercing, but doesn't also talk about tattooing, I don't want to see it. I only want to see it if it has both, right? With or, tattooing or piercing, now what you're saying is, show me everything. I want to see everything. You know, if it's about tattooing only, or piercing only, or both, or whatever, I don't care. I want to see it all. Just show me everything. Or it can also come in handy when you have a thing that can be described by more than one word. So for example, cars or automobiles. If you're searching for cars, what if there's something out there that doesn't have the word car in it, but it does have the word automobiles? Well, you'd want to see that too, right? So, or it can come in handy when you have a situation like that. It can also come in handy when you are searching for seals and you pictures of a seal, the animal, and you get this guy, right? Seal, the singer. And I have to say that Google is getting better at helping you in situations like this. So if you're searching for pictures of a seal on Google Images, it will actually kind of ask you, it'll give you a selection, and if you're really looking for Seal the singer, it will enable you to, it'll help you out with that. But other times, it doesn't. Like, here's an example of that. What if you're doing a research paper on hurricanes in Miami? Like Hurricane Andrew. And you go into Google and you type hurricanes Miami, you're going to get stuff about storms, but what else are you going to get? Obviously. You are going also to get a lot of this stuff, right? Miami Hurricanes, the University of Miami football team, or other sports teams. So here's a situation where not could come in handy because, this is something that you're not interested in. So you could try something like not football or not sports. It's not going to work perfectly because Google is very huge and messy. And, there are all these algorithms going on behind the scenes in Google that sometimes get in the way of Boolean. But you could try that and it should help a little bit at least. Right. Now you have to be careful with a not search because sometimes you run the risk of excluding too much. So for example, you might think, well, what if I say Hurricanes Miami, not university? Wouldn't that get rid of all of the University of Miami sports teams? Well, yeah, but think about it. The National Hurricane Center, where is that located? The National Hurricane Center is actually located on the campus of Florida International University. So if you exclude the word university, you run the risk of not getting anything from the National Hurricane Center, and that's actually the kind of thing you want. So you do have to be careful sometimes with a not search. All right, so before we take a look at how this works in Google, let's see if we can predict what some of our results might be. So which of these search statements will probably retrieve I can't because I apologize. I have things on my Zoom screen that are in my way. So which search statement will probably retrieve the most results of these three choices? Cloning, cloning and ethics, or cloning or ethics? What do you think? Somebody say, someone says B. Is that your final answer? C, correct. It is actually C, cloning or ethics, because A, you're asking for everything about cloning. B, you're asking only for those things that contain both cloning and ethics. So it's a more specific search. And C, cloning or ethics, you're asking for everything. You're asking for everything about cloning, regardless of whether it has to do with ethics or not. And you're asking for everything about ethics, regardless of whether it has to do with cloning or not. So it's, this is going to be the biggest search. How about this one? Which search statement will probably retrieve the fewest results here? Cloning, cloning and ethics, human cloning, or human cloning and ethics? Which one will probably, and notice I'm saying probably, not absolutely for sure, because again, Google is, it's huge. But in this case, it will probably be what? Someone says A. I think we have a C in here. D. Correct. We have a winner. The fewest results will probably come from D because it's the most specific search. And a lot of students find this confusing. Some students think that the more words you type in to Google, the more results you're going to get. But actually, it's the opposite. Usually, not always, but usually, the more words you type in, the fewer results you're going to get because you're getting more and more specific about what you're looking for. How about this one? Which search statement will probably retrieve more results? Art Deco and Miami or Art Deco not Miami? Probably. A or B? Someone says A. Is that your final answer? It is B, probably. Art Deco, not Miami, will probably give you more because Art Deco and Miami, again, is asking, what you're asking for are only those things that are about both, Art Deco and Miami. In B, you're asking for everything about Art Deco, just not the stuff that also happens to be about Miami. So it's probably going to give you more. And here's the last question I'm going to ask you before we take a look at this. Which search statement will probably retrieve fewer results? Art Deco not Miami or Art Deco or Miami? A or B? What about now? A, fewer is, you are correct, A. Art Deco, not Miami. Again, because Art Deco or Miami, you're asking for everything about Art Deco, regardless of whether or not it has anything to do with Miami, and everything about Miami, regardless of whether or not it has anything to do with Art Deco. So the way I remember this is or is usually more. It rhymes, right? Or is more, or it's usually more. Okay. So let's look at how this works in Google. All right. And again, I have to move things away from, I'm sorry, I have all of these. I don't know if you've ever presented in Zoom, but when you're presenting in Zoom, you have all of these windows open on your screen that get in your way. Okay. So when you do an and search, let me back up for a second. When you do an and search in Google, you don't have to type in the word and. Google just assumes that if you type more than one word in your search, you are only interested in things that have all of the words that you're typing in. So every time Google sees a space, it just kind of implies, or it's an implied and. It just assumes that you have an imaginary and in there. For or in Google, if you want to do an or search, it's a good idea to put the word or in capital letters to alert Google to the fact that you're using a Boolean operator. I think there's also a symbol you can use. I think it's the straight up and down line also works for an or search. And then if you want to exclude something from a search or subtract something from your results, well, how do you subtract something in math, you put a minus sign in front of it, right? So if you're trying to say Art Deco, not Miami, you don't type in the word not, you just put a minus sign directly in front of the word you want to exclude. No spaces, just right in front of it. So let's look at our results here. Notice again that our and search is the smallest number, 28.4 million. Our or search is the largest number, 960 million, which is, kind of insane. And our not search came out somewhere in between, right? 437 million. And if I do a search like Art Deco Miami Beach, which is essentially art and deco and Miami and beach, I get the smallest number, 21.2 million. Now, these are still big numbers, but you see how that works. Here's an example of a not search. And again, not is a little weird. So, if you do these searches and it doesn't come out the way I've demonstrated to you, it doesn't come out the way you're expecting, don't be emailing me and saying, Jenny, but it didn't work. Because again, Google is big and messy and there's all these algorithms going on behind the scenes that get in the way. But, every once in a while, you do have a situation where a not search comes in handy. And here's an example of that. One time I was doing another presentation and I needed pictures of Sports Illustrated magazine covers. So I typed in Sports Illustrated cover and I got a lot of this, but I also got a lot of this, the Sports Illustrated swimsuit issue covers, which is not what I was interested in. So I thought, okay, I'll do a not search. So I did Sports Illustrated cover, not swimsuit, and it worked like a charm. I mean, I still did get some swimsuit issues, but it helped a lot. So, you can try a not search and see if it helps. It, may not help completely, but it may help a little bit. Now, you may also be aware of the fact that in addition to Google, you have other research tools available to you as students and faculty and staff here at Miami-Dade College. We have a suite of over 100 different library databases that contain articles and videos and newspapers and magazines and all kinds of ebooks, all kinds of materials that have been selected because they meet the typical research needs of a typical college student. And these, a lot of these databases also support Boolean searching. In fact, in a lot of these databases, Boolean searching works really, really well. So here's a screenshot, for example, of one of our most popular go-to databases called Academic Search Complete. And if you notice, the Boolean is kind of embedded in here. I mean, they give you these operators that you can, work with and manipulate. So you can do a search like social media and mental health. And, if you get too many results, you can keep going and you can even use Boolean operators, within, what you're typing. And that works especially well with or. So you can say social media and mental health and teenagers or young adults. You can do something like that. Here's another example. I was helping a student who was doing research on medical marijuana. And a lot of what was coming up was stuff about the legal aspects of it, the laws and legislation and everything. And that was not what she was interested in. She was interested more in like the therapeutic uses. And she was also interested in the agricultural aspect, like cannabis farming and stuff like that. So this time we tried a not search and we did medical marijuana, not laws or legislation. And that worked really well for us. That helped a lot. And here's another one that's kind of interesting. If you're searching for something like sustainable architecture, you could say architecture and sustainable or green or eco-friendly, right? Depending on how something is expressed, you're saying you want to get it all. And the reason I like this one is because this one really reminds me of math. So let's take a closer look at it. So when you're doing a search like this one, you're actually essentially doing 3 searches at once. You're searching for sustainable architecture, you're also searching for green architecture, and you're also searching for eco-friendly architecture. And you could do each of these searches separately, but with or, you're doing them all at the same time. And you know what this reminds me of? It reminds me of stuff like this, right? Remember this from math class? If you ask it like x equals 2a plus 2b plus 2c, and notice you have a 2 3 times here, okay? Can't you, and math people, correct me if I'm wrong, but can't you, like do this? Can't you like factor out the 2 and put the rest of it in parentheses? I think you can do this, right? And you still get the same result. And remember what happens, remember your order of operations, right? In math, anything in parentheses, you do it first. Actually, I think you're supposed to do exponents first, but you do that first. So instead of saying 2 times a plus 2 times b and then 2 times c, you're saying just add up a plus b plus c and then multiply it by 2. It's a little bit more efficient, right? And it's the same with a search like this. If you're searching for sustainable architecture or green architecture or eco-friendly architecture, you can do the same thing. You can factor out the architecture, right? And put the rest of it in parentheses. And in the databases, you don't have to use the parentheses, but this is indeed how you would type this if you were using Google. You would put the or pieces in parentheses, right? So what Google is going to do is it's going to do what's in parentheses first. It's going to search for everything with the word sustainable, everything with the word green, everything with the word eco-friendly, but then it's only going to show you out of those bazillions of results it probably got, it's only going to show you the ones that also have the word architecture. Here's another example. Cars, right? You want self-driving cars or driverless cars or autonomous cars. And this is a way that you could do this. And another example here, if you're searching for hearing loss and you want, hearing loss as a result of loud music or hearing loss as a result of headphone use, you could do it this way. Now, there are a lot of other things that you can do in Google to refine your searches, and a lot of other things that you can and not into your searches besides words. Like, for example, you can tell Google that you only want or don't want results that come from a specific domain, like .com or .gov. You can tell Google that you only want things that are a particular file type, like PDF files or something like that. You can specify a date range. You can specify a language. There's lots of other things you can do and lots of Google commands that you can use that will do this for you. You can tell Google that you only want things that have the word architecture in the title of the thing. So lots of different things you can do. And I'm not going to get into that now because that, honestly is like a whole other session for a whole other day. But in the meantime, I do want to let you know, and maybe you are already aware of this, but some people are not. If you're ready to level up your Google searches and get, a little more complicated, Google does have an advanced search. Just, Google it, Google Advanced Search. And this will help you if you don't know the Google commands. It will help you to, really craft these searches. I think it's more fun to kind of do it yourself, but you can get really, really advanced with Boolean and do all kinds of nested searches and everything. But anyway, and then also, I also want to let you know that coming up is another Research Thursday session with our own Aaliyah Shields, who's here in the room with us. She's going to be talking about getting the most out of Google Scholar on December 7th. So you can attend her Research Thursday too. And, there's a lot of really cool things you can do with Google Scholar. And one really kind of like important thing that a lot of people don't know about that you are able to do as college students here at Miami-Dade College with Google Scholar. It's sort of this like magical thing that helps you. And I'm not going to tell you what it is. I'm going to leave you in suspense. So go to Aaliyah's workshop and learn more about how to use Google Scholar more effectively. Okay. All right. So to review, Boolean searching, use and when you get too many results and you want to narrow down a search, use or when you want to broaden a search and get more, and use not when there's something you want to exclude from a search. Okay, now just to kind of like finish up here, just to have a little fun with this, I came across this Venn diagram of a life of a college student. So we have 3 sets here. We have a set of students who get enough sleep, a set of students who have a good social life on the lower left there, and the set of students who get good grades. So according to this diagram, you are a nerd if A, you get enough sleep and you get good grades. B, you get enough sleep or you get good grades. C, you get enough sleep but you do not get good grades. Or D, you get enough sleep or you are a slacker. Which is it? This should be an easy one for you. It is indeed A, right? If you get enough sleep and you get good grades, maybe you don't have the best social life in the world. I don't know. Or I don't know. Nerds are known to party every once in a while. So I hope that all makes sense for you. That is my show. Does anyone have any questions or comments? And I do have a link to a survey here, this QR code.
Will you send us a recording?
We are recording, and yes, I shoot me an email, and I will. Okay, we have your email now. Okay, good. Yes, we will send you the recording. No problem. Okay. And I think you can find the recordings of all of the Research Thursday sessions at the Learning Resources on the Learning Resources YouTube playlist. So if you go to the Learning Resources homepage from the college homepage, you'll find the sessions there. Any other comments or questions? Does it make sense? Do you think this will be helpful to you when you're searching? Yes, good. I'm glad about that. It would be. I hope so. I hope so. Again, it's not perfect. It doesn't always work exactly the way you want, but it can be helpful.
Thank you, Jenny, for a wonderful presentation.
Thank you, and you've seen this show before. So.
Yes, and every time you get better and better.
Thank you so much. Thank you all for coming.